We're asked to evaluate the derivative of this. We cannot just start using quotient rule here, because I'm saying something. I'm saying that this is 3 plus x over 5, and we can factorize this. If you could remember, to factorize this could be written as 7 over 3x minus 5. And this is 3 plus x over 5. So s over 5 plus 3. S over 5 plus 3, they are the same. So this is just the derivative of the derivative of this. So that if you open up this, you get back what we have here. So we'll reduce. So this is just derivative of 7 over 5x minus 7 over 3 x minus 5. So which is just derivative of 7 over 3x is 7 over 3. While derivative of minus 5 is 0. So the answer is 7 over 3. So it's very simple. Whenever you are given this, try to know whether you can factorize and reduce before you do the normal derivative. So this one, we asked find the derivative of this. So we are asked to find the derivative of this. That's derivative of x cubed minus 1. And you know 1 could be written as 1 cube. So I'm going to apply difference of 2 cube here. This is the same thing as derivative of, from difference of 2 cube so this is difference of 2 cube. So you know the formula. So once you expand this, you get back this. And what do you notice? So this is just derivative of x minus 1, because this is gone. So which is 1. So the answer is A. We have to find the derivative of this to the simplest form possible. Okay. We ask that's the derivative of x cubed minus 2 over 3x plus 1 over 9. Okay, if you, as you can, this is squared and this is 1 over 3 squared. This is a perfect square. So I'm seeing that this is a perfect square. So we can write this as x minus 1 over 3 all squared. If you expand this, as you can see, x squared 2 times this is minus 2 over 3x, and 1 over 3 squared is 1 over 9. So we are still correct. So I'm applying laws of indices. We can write this as the derivative of x minus 1 over 3. 2 times 3 is 6. The chain rule combined with power rule. So this is the same thing as we differentiate this thing as number, that is, which is equal to 6 times x minus 1 over 3, 6 minus 1 times the derivative of inside, which is x minus 1 over 3. So you differentiate as if you are differentiating using power rule. 6 times this, 6 minus 1 times derivative. If you could remember our power rule. So this is now 6 bracket x 1 over 3. 6 minus 1 is 5. And this derivative of this is 1. So no need. So that's our answer. Times 1 is the same thing. So our answer is that. So the next question. So we asked to find the derivative of that. So what we have to do is to reduce this. So we have to find the derivative of x minus 1, 3x minus 3 all squared. So we can't just start using quotient rule. So it's better we just we'll simplify before we find the derivative. So we can bring out 3 is common in, so you factor 3 out. So this is derivative of x minus 1. You know, we can write this from indices product. That's product of two numbers raised to a power is the same thing as raising the power. Raise the 2 to the power, which is 3 squared x minus 1 squared. So using laws of indices, so which is as derivative of x minus 1, this is 9x minus 1 squared. So which is 1, because this is remaining 9, that's the derivative. 9 bracket x minus 1. I know we can bring out the, because we have 1 over 9. 1 over the derivative of 1 over x minus 1. So we know we can still write this as over 9 d over dx. Yeah, we can write this as x minus 1 raised to power minus 1. So again, using our chain rule combined with power rule, which is now 1 over 9 minus 1 times x minus 1, as I'm differentiating this, minus 1 times derivative of inside, which is x minus 1. So we have this minus, so we have minus 1 over 9 x minus 1 raised to power minus 2. This times 1. So the answer is minus 1 over, you can bring this down, 9 over x minus 1 raised to power 2. So that's our answer, the option. Okay, from what we are seeing, the option should be A. It's A now. The answer is A. Why? Okay, let's finish up. This is minus 1 over, you know, 9 is 3 squared, so which is 3 squared x minus 1 squared. So we can bring the 2 together. We can bring the 2 together in squared. So which is 3 times x minus 1 all squared. Finally, which is minus 1 over 3x minus 3 all squared. So our answer is A. They are the same. The answer is A. So the next question, we are asked to find the derivative, find the first derivative of x over sine x. Looking at this quotient, we have to use quotient rule here. But looking at the option, it seems nothing like quotient. So it's better we write, instead of writing this, we asked to find the derivative of x over sine x. I know this could be written as x times, you know, this is 1 over sine x. So this d over dx of 1 over sine s is cosec x. So we ask, use our product rule. This is our u and this is our v. So we have u dv. So the derivative of this is now u, which is x, dv. That's the derivative of cosec x plus v cosec s, the derivative of u, which is x. So I just applied u dv plus that's the v over the x plus v du over the x. That's why, because of that. So let's continue. So x, derivative of cosec s is minus cot x cosec x. That's the derivative of cosec x plus cosec x. Derivative of x is 1. So as you can see, okay, our option, if you notice, cosec x is common in both, so we'll factor cosec x. If you factor cosec x, so in this first bracket, if we bring out cosec x, we are left with minus x cot x plus 1. So our option is A. So A is the answer.